On September 21, 2022, NASA's Goddard Space Flight Center sent images of the icy giant Neptune to the command center. It was going to be a moment of unprecedented significance in the history of space exploration by man, and that of Neptune specifically. The images captured would enthrall people across the world and greatly modify our belief of Neptune as a planet. What makes the new Webb images of Neptune and her ring so special? NASA's Webb telescope holds the record for being the world's biggest and most powerful telescope, operating at a distance of 1 million miles from Earth. It was sent to space in December 2021 to provide high-definition pictures of planets for further studies. The new glamour shots of Neptune, as per the ones released by NASA, give a different look to the sinister planet sitting at the farthest end of the solar system. The pictures not only focus on the ring system around Neptune, but also brings to light certain faint dust bands that were never seen before. 7 of its 14 known moons too came to the limelight because of Webb. So what makes the Webb superior to other telescopes? One of the key features is its use of infrared radiation to create better quality pictures. These waves have greater penetration power than visible light and can penetrate certain kinds of haze or cloud cover, allowing pictures of distant objects which are not visible to the normal camera to be visible on the picture. Another advantage is that the radiation, being a carrier of heat, makes visible the long-range heat wavelength emitted from faraway objects. The Webb, which is a brainchild of NASA, costing the parent company around $10 billion, was created to peer into our deeper areas of the universe and to be able to bring back pictures of the beginning of the universe. How is that supposed to be possible? How can Webb bring back pictures of an event that happened 20 billion years ago? Well, the key lies is in the fact that distances in space are measured in light years. It means that light takes years to travel meager distances in space and at the farthest corners of the solar system. It's possible to capture the light that was emitted years ago during the Big Bang and focus it on a photographic plate. Neptune is the 8th planet from the Sun in the solar system and at a distance of 4.5 billion kilometers from the nearest star. The planet is also the farthest in the solar system, with a mass 17 times the mass of Earth. Neptune is only slightly bigger than its near twin Uranus. Its greater mass causes more gravitational compression of its atmosphere and hence smaller than Uranus, although it ranks as the densest planet. It's composed primarily of gases and liquids and doesn't have a well-defined solid surface and is often referred to as the ice giant. One of the most famous characteristics of Neptune, widely publicized in children's books, is its fascinating rings. These were first captured in camera by NASA's Voyager 2 during a flight past the gaseous giant in 1989. At that time, the intrigued space scientists vowed to return to Neptune as soon as possible, but they were not aware that it would take over 3 decades for them to reach the same place. Neptune has always fascinated researchers since its discovery in 1846. Located 30 times farther from the Sun than Earth, the icy giant orbits in the remote, dark region of the outer solar system and takes 164 years to complete one revolution. At such an extreme distance, the Sun is expected to look minuscule and faint, such that at high noon on Neptune, the Sun would vaguely resemble a dim twilight on Earth. The rings of Neptune are a group of 5 principal rings that were first discovered on the 22nd of July 1984 by Patrice Boucher, Reinhold Hafner, and Jean Manford at La Silla Observatory in Chile. At their densest, the rings are comparable to the less dense parts of Saturn's main rings, like the C ring and the Cassini division, but still, the majority of Neptune's ring system is composed of tenuous, faint, and dusty rings, closely resembling the faint and almost invisible rings of Jupiter. The 5 distinct rings are named in order of increasing radius from the planet as Gall, Leverrier, Lassell, Arago, and Adams. In addition to these well-defined rings, Neptune also possesses an extremely faint sheet of intergalactic material stretching inward from the Leverrier to the Gall ring and deeper in towards the planet. 3 of the Neptunian rings are narrow, with widths of about 100 kilometers or less, while the largest include the Gall and the Lassell ring, with their widths varying from 2,000 and 5,000 kilometers. The Adams ring is unique in consisting of 5 bright arcs embedded in a fainter continuous ring. 4 small Neptunian moons of its total 14 have orbits inside the ring system. The majority of the Neptunian rings contain a large quantity of micrometer-sized dust having a cross-section area of between 20 and 70%. They're similar to the rings of Jupiter in terms of dust fraction, but very different from the rings of Saturn and Uranus, which contain little dust of around 0.1%. The particles in Neptune's rings are composed of a mixture of ice with radiation-processed organics, giving it a dark outward appearance. The rings are optically thin and transparent, and their normal optical depths do not exceed a 0.1 ratio. The concentration of helium and methane in Neptune are much higher than on any planet, as seen by the bluish appearance of Neptune in Hubble Space Telescope images set at visible wavelengths. However, in the recent pictures released by the Webb, Neptune doesn't appear its characteristic bluish hue, as Webb's near-infrared camera objects in the near-infrared range from 0.6 to 5 microns. Neptune looks very dark as most light is absorbed by the methane, except in the areas with high concentrations of methane clouds, which appear as a bright streak owing to their reflection of sunlight. The images also show a thin line of brightness circling the planet's equator that's expected to be a visual signature of global atmospheric circulation that causes strong winds and storms endemic to Neptune. The atmosphere descends and is comparatively warmer at the equator. Hence, the central region of Neptune has a characteristic glow, especially under the infrared wavelengths more than the surrounding gases, which are cooler. Neptune, being the farthest from the Sun, has an orbit span of 164 years. That means that its northern pole, seen in the image, is usually out of view of astronomers. The Webb image, though, hints at an intriguing and unprecedented brightness in that area. As for the South Pole, the Webb image has not only verified the presence of a vortex previously known, but also revealed a continuous band of high-latitude clouds surrounding it. Webb images also captured 7 of Neptune's 14 known moons. Dominating the Webb portrait of Neptune is a very bright point of light exhibiting the signature diffraction spikes seen in many of Webb's images. This was believed to be an unusual discerning factor of Neptune, but is now not considered a star. Rather, it is Neptune's large and unusual moon Triton. As Triton is covered in a frozen sheen of condensed nitrogen, this huge moon reflects an average of 70% of the sunlight that falls on it. This gives it a shiny texture and helps it outshine the planet Neptune. Additionally, Neptune in any Webb image looks darkened because the planet's atmosphere is rich in methane, which absorbs instead of reflecting these near-infrared wavelengths. Triton orbits Neptune in a special backward orbit, also known as the retrograde orbit, leading major conspiracy theorists and astronomers to speculate that the moon was originally a Kuiper Belt object whose path was altered by the gravitational force of Neptune. Can we expect more from the Webb telescope in the future? A superficial observation of the telescope informs the scientists that it's in a very fine state of health. The only problem for NASA would be the state of order for certain instruments on the rover. A report a few weeks before the images showed that a few instruments displayed signs of wear and tear, primarily due to friction between components. Friction can happen as a backdrop to the high speeds attained by the spacecraft while traveling through space, or due to friction between moving parts. The defective instruments belong to one of the 4 observation modes on the scope, and all operations in that particular mode have been reported and closed down. However, despite the setback, it is expected that the Webb satellite will continue to send us high-definition pictures that'll continue to baffle us and ask us the question over and over again. Is our understanding of space in general and Neptune in particular perfect? Let's know in the comment section.